G'day. In this video I migrated the netProbe from using micropython on an ESP32 to using Python on a Linux device. I'm using an Orange Pi Zero because it's a similar form factor to an ESP32. I'll walk through the steps to set up the Orange Pi and then look at the changes I need to make to the actual ESP32 version of the netProbe to get it running. Finally, I'm going to do some network sanity checks just to make sure netProbe is reporting valid ping, which is latency, and bing, which is bandwidth numbers. Then probably in the next video, I'll wrap everything up and put this netProbe into a Docker container. And I'll make deployment easier to other devices. So for my Linux box, I'm going to use an Orange Pi Zero. It's about $33 on Amazon. I kind of like it because it's got a built-in Ethernet adapter as well. Then the operating system I'm going to use is Armbian, which is made for it, and here's where you can get the Armbian download. Okay, let's look at how I set up Linux on the Orange Pi Zero. So first I used Armbian as the Linux version that I'd flashed to it. Seems to be the latest that Orange Pi is supporting. So I flashed Armbian image to an SD card and plugged that into the Orange Pi and started the Orange Pi. Then I went to find the Orange Pi on the network, so I just scanned my local network. It showed up as Orange Pi, and I could connect to it using SSH as root, and the default password was 1234. When you do that, when you first go into it, it's going to ask you to update the root password, and also to ask you whether you want to create a new user. So I did. I created a Pi user. So it's set up pretty much like a Raspberry Pi. Once that was set up, then I logged out, logged back in as Pi. I did a sudo apt update and a sudo apt upgrade just to make sure I had the latest version of things installed on my Orange Pi. After that was done, I did a lsb_release-a just to see what Linux version I had installed. And it actually said it was Ubuntu 22, so nice recent version of Linux. Then I ran sudo orange pi config, and this is an optional step, but that brings up a config utility that makes it easy to set a static IP address. So I wanted to give my Orange Pi a static IP address. I did that, saved it, and then had to reconnect with the new IP address. Next step was to install Flask. So first I just checked the version of Python I had. So I did a Python 3-V, and that told me the Python version I had was 3.10, which is a fairly recent version. That's good, so I went with that. So I just had to install pip, so I did a apt install python 3-pip, and then I did a pip3 install Flask to get Flask installed. I wanted to test that Flask that I just installed was working, so I did a make directory my Flask app, changed into that directory, and then used nano to put these commands in to make a simple hello world type Flask application. Saved that using nano, and then I did a python 3 hello.py, which ran the Flask application and gave me the IP address and the URL of what I'd click on to make sure that this Flask application was working. For me, it was working. The final step was just to install Docker, so I did a sudo apt get install docker.io. That ran through, and then after that, just to check that Docker was actually running, I did a sudo system control status docker, and that told me about version of Docker that's running, what its status was, and also gave me the end of its log. So that was good. It told me Docker was installed and running. So at this point, I think my Orange Pi is ready to use for doing some development work. I saw on the web that these Orange Pi Zeros can run a bit hot, so I thought I'd measure the temperature before I got too far into this. And looking at the CPU and RAM and things, and nothing seemed to be above about 40 degrees centigrade, which is fine. So I'm going to use Remote Explorer to program on my Orange Pi. So first I'm going to open that, and it opens a config file. I've already got a couple of hosts already in there, so I'm going to add in the Orange Pi. So it's just an SSH command to connect to it. H pi. I'm going to say I'm going to keep it in the same config file. So that's good. So let's connect in the current window. So it's going to ask me for the password. And this is just my normal SSH password. So when you first do this, it needs to download some folders and things onto the Raspberry Pi. So you see down there it's setting up the Orange Pi requirements. And we're good to go. So let's connect. So I'm going to connect to this folder here, netProbe scheduler. So that's the one I'm going to be working on. So we're all ready to go. So it's out on the Orange Pi, so I can start doing things like adding files. So let's make one called shed.py, and that's just a normal Python file, and I can do all the normal things. So open up a terminal, it drops me into the folder I'm working in. I can do normal Linux commands here, and the other thing I'll do is I'll put this into a repository to hold the code. Okay, here's my plan for making a Linux version of netProbe. So I'm using two resources. So a few years ago I did the OurProbes version of this, and I've done a version that ran with just pure Python, not micropython. So I'm going to use those libraries for doing the ping, bing, and web page, and there's some supporting libraries behind these, and bring those libraries in for doing the network things in my new Linux version of the scheduler called netProbe scheduler. So I'm actually going to separate what are both in the same main process in the netProbe into two separate processes, one that's doing the scheduling and that can run separately from the actual netProbe Flask side of it, where it's responding to web requests. And because I'm running on Linux and I can run separate processes happily, this is going to be the easier way of getting the whole thing together, and I don't have to worry about async IO where processes can clash with each other. I can just let the operating system run them independently. So I'm going to have this netProbe scheduler, so I'm bringing in the network libraries that I was using in the OurProbes Python device version of it. And then from netProbe, I'll bring in the rest of the libraries. So the thing for managing the list of hosts, the thing for writing out logging messages, and the thing for this net logger that actually writes out the details from all the host tests. And I'll put those parts into the netProbe scheduler, and like I said, I'll take just the scheduling section of the main Pi from netProbe and put it down here as the complete program for the netProbe scheduler. And then like I said, I'm going to have a separate program called netProbe Flask, which will have the web interface capabilities. So it's going to have Flask in it. Still support all the same network services as netProbe, so I can use the same netProbe UI with that and just point it at this one. And I don't think I need to make any changes to netProbe UI. Maybe I just need to change where I set the relative epoch date, whether it's 1970 or 2000, because in MicroPython it uses 2000, at least on my version of an ESP32 version. It starts the epoch date from 2000, whereas in Linux it starts it from more the Unix time of 1970. So I think I'll have to take the configuration parameter I've got in the environment out and make that another runtime configuration parameter over here, so that I don't need to change netProbe after that. I just change the configuration parameter to say whether it's got a 1970 or 2000 based epoch time. So that's the plan. So let's have a look at what it looks like in VSCode. So let's look at the implementation of the plan. So again, back into VSCode, it's using Remote Explorer to connect up to my Orange Pi 0, and I'm connected in as user Pi, and I'm in the netProbe scheduler directory, which is where my project would be. And so these are the files I've now got in there. And again, I just took the approach of getting all the crooks in the same room. So basically I just pulled all the libraries I thought I needed, as shown in the previous slide, into netProbe scheduler, and I had to fix up a few things, but it wasn't too bad. So now my main just looks like the scheduling section of the netProbe program, so a lot simpler. So I've still just got the scheduler that sits in a loop and runs through the ping, bing, and web requests section, but now it's calling the Python-based libraries for pinging and bing and web page rather than the micropython-based libraries. And that turned out to be easier than I thought. Everything sort of hung together. I had some little differences in how I was calling some of the functions, but it didn't take too long to fix those up. And I've put all the libraries I'm using down in this lib directory, and you see one thing I had to do was add lib to the sys path for this instance, just so it could find the modules in this library folder, whereas in MicroPython it's just using that folder as a default folder for finding libraries in MicroPython. Let's see if this works. So I'm just going to do a sudo python 3 and run main. And I've got quiet turned off, so it's telling me everything's happening, but you can see it's just doing the same as before. I've actually got the same host file as I'm running in netProbe, so I just copied that over. So first it's doing my host.New Zealand, and it's doing pings and bings, and it'll do a look at the web page as well for that, and it's going to run through all the same hosts. One nice thing about using Linux is I can use a larger ping size, so I get more accurate Bing results if I ping with this larger size here. So I'm using a 5,000 byte ping. Not all websites or all hosts are going to accept that. It depends on whether they support fragmented pings or not. So there's something that happens. You'll see an example of it here with Lupincorp. It goes out, tries to do a 5,000 byte ping, fails, it's not getting any response, so it's given up, and you'll see it then dials back to a 1,400 byte ping, which everything should accept. It makes the Bing calculations of the bandwidth a little less accurate, but it'll still show me the trends in most cases. So I either get a more accurate one, or it dials back to the same sort of accuracy as I got on the netProbe. So it looks like the schedulers are all working. Let's work on the Flask side of things. Okay, I did a little cleanup of this project. So I've actually renamed the project to netProbeLinux. So you'll see up in GitHub, that's what it's called now. So that's the reference I'll put down in the description to the Linux version of this netProbe. And what I wanted to do, the reason I did that is I just want to have two main Python routines running. So you fire up scheduler, and then you fire up, what I'm going to put in here is kind of the Flask program to do the web requests, and have those both be fired up and running at the same time. But the Flask application is going to use these same libraries, so it's easier just to put it in the same folder here and keep everything together. So netProbe Linux will now contain the scheduler program and the Flask program. And you saw I changed what I'd called main to scheduler.py now. And let's just make sure everything's still working here. Fire it up. And you can see it's reading hosts, doing pings, so I feel fairly sure that this means everything's working now. So I have the actual Flask web services running as a separate process, so this webservices.py contains that script. And some of the changes I had to make from the original microDot version of Flask was pull in the Flask cores interface. So that's similar to microDot, where I had to bring in the microDot cores interface, but it's called Flask cores. I had to do an npm to bring that in. I set up the cores interface, and down, one thing that was different was down in the after request where I was sending back allow access control, allow origin from anywhere, and really that's for testing. It makes it easy to test from another machine. It wouldn't work with when the request was for options. Options would not like it. Back at Angular, it would say that I was setting an incorrect response header when it used in combination with options and cores. So basically just said if it's options, then don't include the access control allow origin into the header. The other thing that was different with Flask from microDot was for all these route statements, in microDot you call out the request item, so it'd be request comma and then the actual route, where with Flask request is just available to you. You do need to import request and send file from the Flask library, but other than that it's a little easier because request is available to you. So there's the major changes. The other thing was again, because I wasn't having both the schedule and the web services running in the same process, my HostStatus was having problems in keeping HostStatus, or the hosts tests object that was in memory for the ESP32 version. I sync through having a file that it writes out, and both web services and scheduler use that file. So I had to do some funny things down in hosts. Sorry, down in the library hosts. When I do things like I had to basically add these two routines, save host tests to a file and retrieve host tests from a file, and you can kind of see it here is just a file version of the host tests that was running in memory on the ESP32 version. So now I'm throwing it out to a file, and the other tricky bit is I had to make sure I saved and loaded it enough times so that to keep the web services and scheduler in sync, to make sure that every time scheduler changed it, it saved a copy. Every time web services changed it, it saved a copy and kept these two in sync and is loading from that copy. Doesn't seem to impact the performance at all. I think that's the major changes between them, and again, the nice thing is it all worked. So once everything was working, final thing I needed to do was just make sure I could get it to start the scheduler and the web services when I reboot the Orange Pi. So the way I did that, so under root I signed in. And we'll just do a cat on, sorry, we'll do a cron tab -e. And so in this cron file, I said when the Orange Pi reboots, run the SSH script that I created called cronscript.sh in the background. And let's have a look at that script. So over here you see in the script I'm just changing into the netProbeLinux directory, and then I'm using Python 3 to run the scheduler.py and Python 3 to run the webservices.py, both as background tasks. So that fires up the two tasks. That seems to work okay. And let's just have a look at what the interface looks like. Okay, so this shows netProbe running now. So one nice thing about it running on a Linux OS is I can support a lot more hosts in my lists here. So I've got about 10, 12 now that I'm using. It seems to run a lot faster too. So if I do things like going backwards and forwards between the pages is really fast, and it's pretty responsive coming back from for the web services. I also set up this main page now, so it refreshes every 15 seconds. So it should show sort of the latest of the current status of all the network probe tests, and again things like the history charts pretty fast now. So it seems to run through all the data for the history and bring back the request for the history pretty fast now, which is good. So let's just have a look at one more. 8 hours, 14 hours, 7 days. So all that's working pretty well. So I'm happy with that. So next stage is I haven't used Docker much, so I want to try using Docker to wrap this whole thing up into just a Docker container, so it's easier to install on at least any ARM Docker instance, and then maybe I'll have a look at seeing about setting up the same thing to run on something like a Synology, which uses a AMD type processor. So I think it's a different container type that I need to base it on for that. I'll see if I can get that done. That'll be in the next video. Just to show you, I put the Orange Pi in a case I got off Thingiverse, 3D printed that, so I'll put the link to the Thingiverse design down in the description below. So I've been wanting to check that my ping and bing readings are accurate. A few years ago when I first wrote the ping and bing routines, I checked them, but I thought I'd check them again. And especially seeing them come out of the Orange Pi with that network adapter, see how accurate it all is. So what I'm using to do this is kind of an old network emulator for Windows Toolkit. So this came out of Microsoft Research, maybe around the 2000s. It's very old. You can't install this on anything more modern than Windows 7. After that, the certification for the network driver for this fails. So I had to actually resurrect an old laptop with Windows 7 on it, and then put this on here. But this is how it works. So to set up a emulation, basically you go in, create a new link, create a new filter, and for the filter I'm just going to say it's going to be IP4 only, protocols all, adapters all, so it will emulate on anything coming through. So let's add that and close this. So we've got our filter here, and for the emulation at the moment I'm just gonna, so what you do is you set up the the network conditions you want to appear on both the upstream and downstream. So for the upstream, I'm just going to put in a latency of 100 milliseconds. And for downstream, I'll just do the same thing. I'll have a fixed latency of 100 milliseconds. So that should get us going. You can see here you can also change things like the bandwidth through here, and I'll use that later to check the Bing routine, but let's just check the ping to start with. So let's say OK, and we start running this, and I'm just going to check the readings I get out of the netProbe. Having this run for half an hour to an hour, we'll see what our chart looks like. So these are our ping results. So the first emulation was with 100 milliseconds upstream downstream, so I'm seeing that as a total of 200 milliseconds latency, which is good. Then 20 milliseconds total delay, and that's what I'm seeing in the charts. And then the third one I tested with 50 milliseconds total delay, and again that's what it's reporting to me in netProbe. The next tests were Bing tests to see what the bandwidth looked like. For the first test I didn't have any bandwidth constraints. I'm basically seeing the 100 megabits per second network adapter constraint. The next one I dialed in 25 megabits bandwidth limit, and then the third one I dialed in just a 1 megabit per second bandwidth limit, and all those results lined up almost exactly, so that's great.